Good evening, sir. I'm Nazeeh Ahmed, and I'm going to represent my homework in control systems. So you gave us like 4 questions, and the first one was obtain y of t for the unit step input, and to get the y of t, we must know the formula first of all, and it equals to gs multiplied by RT. So what is RT? RT here is the unit step input, and it is 1 over S. So it's like already given. So how we get this? First of all, let's write it in organized way. Y of t is equal to 4S plus 20, so 200, and we have S multiplied by, we can factor this into two brackets. The first one is S plus 10 and S plus 20. Now it's ready to be solved with the partial fractions way, and we can say can consider like three variables, k1, k2 and k3, and let's say 4s plus 200 over s multiplied by s plus 10 and s plus 20 is k1 over s plus k2 over s plus 10 and also k3 over s plus 20. Let's solve it like this. So we have to get the value of k1, we are going to multiply this equation by the denominator of k1 and also for k2 and k3. So let's get k1 first. To get k1, we are going to replace this s in the first equation, so it's going to be 4s plus 200 over s plus 10 multiplied by s plus 20, and let's consider s is equal to 0, so it's going to be 4s is 4 multiplied by 0 is 0, and also 200, so we have 200 here, and here there is s square and 20s plus 10s, and we have also 10 multiplied by 20, so it's also 200, and it becomes 1, so k1 is 1. Now let's move to k2, and it's equal to the first equation, this one, but we are going to remove the denominator of k2, so it was s plus 10, going to remove it, and we have 4s plus 200 over s and s plus 20. So to get the k2, we are going to consider s is 10, or negative 10, so it's going to be 4 multiplied by minus 10, and it is minus 40, and there is also 200, so it's going to be 160. And there is also in the denominator minus 10 here, minus 10, and here also is minus 10, so it's going to be minus and it's going to be minus 100. So it is minus 1.6, and this is for K2, minus 1.6, and there is also K3. So we have 4s plus 200 over s multiplied by s plus 10. The process is we are going to remove the denominator of K3 from the first equation here. So we are going to consider s as minus 20. From where we get the minus 20? From here. So 4s and s is minus 20, so it's going to be minus 80 and 120. So, and we have here minus 20, minus 20, so it's going to be minus 200, and it's 0.6 with a negative sign. So we have K1 and it's equal to 1. We have K2 is equal to minus 1.6, K3 equal to minus 0.6. So we are going to return to our original equation, and we have 4s plus 200 over s multiplied by s plus 10 and s plus 20 equal to, instead of K1 we are going to put its value, and it's 1 over s plus minus 1.6 over s plus 10 and minus 0.6 over s plus 20. And we have a formula and it says that 1 over s is equals to 1 if we transfer it with the Laplace transformation. So it's going to equal to 1, and we have this formula also for this type of equations. So it's going to be 1.6 here, 1.6 with a negative sign, and also e to the power of the denominator here plus 10. So we have here minus 10t. The minus is from the equation itself. So if we get here s minus 10, it's going to be here e to the power 10 in the positive sign, not in the negative. Now we have 10 is positive. And also for the s plus 20 in the denominator here, it's going to be reduced to the this shape. So we are going to apply the same transformation. So it's going to equal 1 minus 1.6 e to the power minus 10 t minus 0.6 e to the power minus 20 t, and this is for the first question. So we are going to move to the next question. Let's return to our second question. So it is basically RLC circuit. So we have uh, several inductors and capacitors and resistors. So how we are going to solve it? To get it, we have to apply the mesh analysis. So we have the first loop and the second loop. So let's get this by applying KVL or Kirchhoff voltage law for loop 1. So KVL at loop 1. So we have Vt is equal to we have just I1 entering the resistor here. So we have the current is I1, so I1 multiplied by R1. It's basic. So we have also the inductor. So the formula for the inductor is the inductor itself multiplied by the derivative of di by dt, and it's going to be L1 di1 over dt. So we are not making the derivative for the whole current, but for I1, just I1. And we have also the capacitor here. So the formula for the capacitor is 1 over C1, which is the capacitor here, multiplied by the integration of I1 minus I2. Why I1 minus I2? Because we have here in the mesh analysis, so the current from I1 is going this way, and the current of I2 is going in the another direction, in the other direction. So it's going to be I1 minus I2. And we have also the resistor, the second resistor. So it's going to be R2 multiplied by I1 minus I2 according to mesh analysis laws. And this is for loop 1. We have this equation, and it's going to equal to 0. So let's move to KVL at loop 2. Sorry for the poor recording. So at loop 2 we have Vt is equal to we have here it's C2 not C1, so we have 1 over C2 and the integration of I2. Why just I2? Because there is no other current is going into this capacitor, the C2 capacitor. So we have also an inductor, and for the inductor we have this formula L2 di2 over dt, the derivative of the current according to the time. We have also this branch C1 and R2. So let's deal with it. So we have 1 over C1 and its integration. We have also I2 minus I1 because we moved from the first loop here. It was I1 minus I2, and now it's I2 minus I1 according to the mesh analysis law. And we also have R2, so R2 multiplied by I2 minus I1, and it's equal to 0. And this is all for the second question. And let's move to the uh, third question. So we have this question. It's about the block diagram reduction, and we have here here this point. Let us move it from here to this point. Why? Because it's going to be easier like this. So I'm going to remove it like this, and it's going to be here. So we have our H2 block, and it's parallel to the G3 block, so it's going to be like this. The parallel rule is we simply going to add it. So we have, sorry, not R, here H2. So we have G3 plus H2, and here after we remove this one, and sorry, it's not going to be simply H2, it's going to be H2 over G2. So here it's going to be H2 over G2. Sorry, I'm bad at drawing. So G3 plus H2 over G2. Another thing, we have here G1, and after it there is G2, but there is a feedback here which is H1. So let's deal with the feedback, and it's going to be G1 over 1. Here is the sign is positive, so we are going to convert it to negative sign, and 1 minus G1 H1. This is for this feedback, so it becomes cascaded to the G2. So we are going to multiply it simply. So G1 multiplied by G2 over 1 minus G1 H1, and we solve it for this. And we have also this feedback which is H3. So we have our block is going to be like this. Oh my god, very bad at drawing. So we have H3 here, and also we have an adder here. No need for the adder, it's simply Y. So G1 G2 over 1 minus G1 H1 over again G1 G2 over 1 minus G1 H1, and the sign is negative here, so it's going to be positive here, plus H3, and it's cascaded to the G3 plus H2 over G2. So simply going to be like this. So let's reduce it again, and it's going to be g1, g2, g3. So we're going to multiply it, plus g1 h2 over 1 minus g1 h1 plus g1 g2 h3. So this is our final result. So this is our last question. Thank God. And it's about state space. We are going to solve it with the matrix. So we have here third derivative, second and first order, and we are going to say that x1 is equal to y, x2 is equal to y prime, and x3 is y, the second derivative of y, and we have also the first derivative of x3 is going to be the third derivative of y, and this is the first derivative of x, and this is also the first derivative of x2, here x1 and x2. So let's get the x3, the first derivative of x3. So we have here our x3 is let's say 2x3, the first derivative of x3 equals to minus y minus, because we move this one from here, this side of the equation, to the another side, to the other side. So it's minus 3, and we have here x3. So x3 here is the second derivative, as we see here. So minus 3 and x3 plus 5 x2 and minus x1, sorry, 2x1 plus rt. We have here minus. So it's clear, I think. So we want just the first derivative of x3. So it's going to be x3 here is equal to minus 3 over 2 x3 minus 5 over 2 x2 minus x1 plus half of r of t. Let's represent it in matrices. So we have x1, x2, x3, the first matrix. We have plus sign and 3 by 3 matrix, and we have here 0, 1, 0. Why there is 1 here? Because we have x1, you have x1 in this, we have x1, it's equal to here x2. So the first derivative of x1 is equal to x2. So we have here x1, x2, x3, and it's 1 from the first derivative of x1 is equal to x2. So we have also x2 is equal to the first derivative of x2 is equal to x3. So we have 0, 0, 1 again, and we have also the x3, the first derivative of x3 is equal to minus 3 over 2 x3. So we have here x3, so minus 3 over 2 x3, and we have also x2 minus 5 over 2 minus 5 over 2, and we have minus 1, and multiplied by this matrix x1, x2, x3 plus this matrix which is going to be 0 here and 0 and half, and the half because of r of t. So we have y, and it's equal to this matrix multiplied by the matrix of x1, x2, x3, and that's it.